Welcome to this expert-level training module on identifying AI workloads. Today, we are taking an intensive deep dive into the specific techniques and technical scenarios associated with text analysis. Welcome to this expert-level training module on identifying AI workloads. Today, we are taking an intensive deep dive into the specific workloads and technical scenarios associated with text analysis. Within the broader field of artificial intelligence, text analysis is categorized as a critical subset of natural language processing, or NLP. NLP is the foundational technology that enables machines to understand, interpret, and respond to human language. While we frequently hear about generative AI creating brand new content from scratch, text analysis is focused entirely on examining existing unstructured text to extract deep semantic meaning, structural relationships, and actionable insights. Why is this workload so vital? Because modern organizations possess massive volumes of unstructured text data ranging from customer support tickets and social media posts to lengthy financial contracts and legal rulings. Without automated text analysis, transforming this unstructured data into actionable intelligence requires thousands of hours of manual human review. By orchestrating specific text analysis workloads, we can programmatically evaluate text at massive scale. Throughout this session, we will break down the primary techniques used in text analysis pipelines. We will explore how algorithms execute keyword and key phrase extraction to index documents. We will examine entity detection, including the critical redaction of personally identifiable information. We will uncover the mechanics of sentiment analysis and opinion mining. And finally, we will break down the algorithmic processes behind document summarization. By understanding these specific NLP techniques, you will be equipped to design highly efficient enterprise data processing architectures. From a development perspective, implementing text analysis means routing raw strings to specific NLP endpoints before the data is persisted to a database. Your application logic intercepts unstructured user input, submits it to a specialized AI service like Azure Language, and receives a highly structured, deterministic JSON payload containing categorized insights that your backend systems can natively understand and process. Take a look at the flowchart on your screen. It visualizes the core pipeline of our workload. Unstructured text data is fed into the NLP text analysis engine, which branches into four primary capabilities: keyword extraction, entity detection, sentiment analysis, and text summarization. Let us begin our deep dive with our first major text analysis technique, key term or keyword extraction. When faced with a massive text corpus, the most fundamental objective is determining the main points or themes discussed within the documents. Key phrase extraction accomplishes this by algorithmically identifying the most important words and multi-word phrases. Historically, this began with simple statistical frequency analysis. After a document is tokenized and normalized, the system simply counts the occurrences of each token, operating under the assumption that the most frequently used terms indicate the core subject. However, frequency analysis falls short when comparing multiple documents within the same dataset, as common words might dominate the results. To solve this, advanced NLP systems utilize term frequency inverse document frequency, or TF-IDF. TF-IDF is a statistical measure that evaluates how relevant a word is to a specific document within a larger collection. It mathematically reduces the weight of terms that appear frequently across all documents, while highlighting unique keywords that differentiate one specific document from the rest. Another highly sophisticated technique is the text rank algorithm, which operates at the word level. Text rank builds a mathematical graph where individual words become nodes, and their co-occurrence within a specific window of text creates the connecting edges. The algorithm iteratively calculates scores based on these connections, ultimately extracting the highest ranked words as the definitive key terms representing the document's main topics. These algorithms are the backbone of modern search and indexing engines. In your application code, implementing key phrase extraction is incredibly straightforward when using cloud-based AI services. You do not need to manually code the TF-IDF statistical formulas or graph nodes. Instead, you utilize the Azure Language SDK to pass an array of document strings to the extract_key_phrases function. The API responds with a structured list of strings representing the core concepts of each document. This diagram illustrates the keyword extraction process. The document corpus undergoes tokenization and normalization before hitting the statistical analysis layer. Here, methods like frequency analysis, TF-IDF weighting, and text rank graph scoring are applied to mathematically determine and output the extracted key phrases. Moving forward, our next critical text analysis technique is entity detection, formerly known in data science as named entity recognition, or NER. While key phrase extraction identifies overarching themes, entity detection is highly granular. It is the NLP workload responsible for scanning unstructured text and accurately identifying specific, named entities, such as the names of people, geographical locations, organizations, dates, and times. When a model performs entity detection, it does not merely highlight a word, it actively categorizes it into a structured hierarchy. For example, if a document states John visited Microsoft in Seattle on May 2nd, the NLP engine will output John as a person entity, Microsoft as an organization, Seattle as a location, and May 2nd as a date-time entity. Modern entity detection models go even further, identifying complex numerical quantities, such as exact dimensions, percentages, and monetary values. Why is this workload so transformative for the enterprise? Because it allows businesses to take dense, unreadable text blobs like hundreds of pages of legal contracts or medical records, and automatically transform them into highly structured, actionable intelligence. By semantically mapping these extracted entities, organizations can populate relational databases, build highly complex knowledge graphs, and automate downstream routing processes. A logistics application, for example, can automatically detect shipping addresses and delivery dates from incoming customer emails, feeding that data directly into the supply chain management system without requiring any human data entry. Implementing named entity recognition involves sending your raw text payload to a pre-trained NLP endpoint. The service returns a JSON array containing entity objects. Crucially, each object provides the category, such as location or person, the exact text value extracted, and the character offset integers. Your code uses these offsets to highlight the entities directly in the user interface, or store them relationally. Observe the entity mapping architecture here. The unstructured text, John flew to London, enters the named entity recognition engine. The system identifies semantic entities, explicitly classifying John as a person and London as a location, allowing this structured data to seamlessly populate a relational database. Building directly upon the concepts of entity detection, we encounter a highly specialized and legally critical workload: personally identifiable information, or PII, detection. In today's digital landscape, organizations frequently process vast amounts of unstructured text that contains highly sensitive personal details. This includes customer support transcripts, survey responses, and account application forms. According to the foundational principles of responsible AI, organizations must rigorously protect this data. PII detection utilizes advanced natural language processing to automatically scan incoming text and identify sensitive entities, such as full names, private phone numbers, physical street addresses, email addresses, and financial account details. The true power of this workload, however, is not just in detecting these entities, but in actively redacting them. When an application routes text through a PII detection engine, the service can automatically mask or remove the sensitive data, replacing a real phone number with a generic placeholder string. This automated redaction step is absolutely critical for maintaining strict regulatory compliance with global privacy laws. If your data science team needs to analyze millions of chat logs to train a new AI model, or if you need to store those logs in a long-term data warehouse for analytics, executing a PII redaction workload ensures that you never inadvertently expose or hoard restricted personal data. It acts as an automated privacy firewall, drastically reducing the organization's attack surface and mitigating the severe legal risks associated with unauthorized data exposure. To implement this privacy firewall programmatically, your backend code must intercept the raw user text and pass it to the PII detection API before any database write operations occur. The service returns a sanitized version of the string, where all identified sensitive entities are replaced with asterisks or category labels. Your application logic then safely stores only the fully redacted output payload, permanently discarding the raw input. This visual demonstrates the automated privacy pipeline. A raw support transcript is sent to the PII detector, which scans for names, phone numbers, and financial details. The system applies an automated redaction mask to these entities, producing a sanitized output that is completely safe for secure, long-term storage. Our next core text analysis capability involves evaluating the overall context and tone of a document through text classification and sentiment analysis. Text classification is the NLP process of programmatically assigning a document to a specific, predefined category based on its underlying contents. A classic, high-volume example of text classification is filtering incoming emails into spam or not spam buckets based on historical keyword patterns. Within this domain, one of the most widely adopted enterprise workloads is sentiment analysis, also known as opinion mining. Sentiment analysis is a specialized form of text classification designed to predict the emotional tone or sentiment embedded within a body of text. Using advanced semantic embeddings, the AI model evaluates the vocabulary and linguistic structure of a sentence to categorize it as overwhelmingly positive, strictly neutral, or decisively negative. Some advanced models can even detect specific emotions, pinpointing frustration, anger, or joy. This technique is incredibly valuable because it transforms subjective qualitative user feedback into objective quantitative metrics. For instance, an organization can automatically route thousands of social media posts, product reviews, and customer support tickets through a sentiment analysis engine in real time. If the system detects a sudden spike in highly negative sentiment regarding a specific product, it can automatically trigger high-priority alerts to the public relations or engineering teams for immediate triage and remediation. When utilizing an SDK for sentiment analysis, your code submits a batch of document strings to the endpoint. The returned JSON object provides an overall sentiment label, such as positive or mixed, along with granular confidence scores ranging from 0 to 1 for each individual sentiment category. Your application logic can use these floating point confidence scores to dynamically route frustrated customers to live human agents. Here we see sentiment analysis driving automated workflows. An unstructured customer review is evaluated for its semantic tone, while positive reviews are logged as success metrics. A negative evaluation immediately triggers a high-priority support alert, routing the issue for immediate human remediation to maintain customer satisfaction. Our final vital text analysis technique is document summarization. In the modern enterprise, professionals are constantly inundated with lengthy documents, massive legal contracts, and hours of meeting transcripts. Summarization workloads solve this data overload by algorithmically reducing the overall volume of text while retaining the absolute most salient points and critical themes. In natural language processing, there are two primary approaches to this workload: extractive summarization and abstractive summarization. Extractive summarization is a technique where the AI model does not generate any new words. Instead, it extracts the most important, highly relevant sentences directly from the original source text to form a concise summary. This is often achieved using the text rank algorithm we discussed earlier, but applied at the sentence level. The algorithm breaks the document into individual sentences, measures the semantic similarity and word overlap between them, and builds a mathematical graph. The sentences with the highest connectivity scores are extracted, guaranteeing a summary comprised entirely of the original author's exact phrasing. Conversely, abstractive summarization utilizes the advanced reasoning capabilities of large generative AI models. Instead of just picking existing sentences, an abstractive model deeply comprehends the semantic context of the entire document and generates completely new, original language to summarize the key themes. This is highly effective for generating executive briefs or concise bullet points from massive, multi-page reports. To implement summarization, developers can use general-purpose LLMs via the OpenAI API by passing a system prompt like, "Summarize the following text in 3 bullet points." Alternatively, for strictly extractive summarization, developers can call dedicated Azure language endpoints, which deterministically rank and extract the highest scoring sentence indices, ensuring the output contains 0 generative hallucinations. This diagram compares the two summarization methods. The lengthy source document enters the workload. The extractive path utilizes text rank scoring to pull a subset of original sentences, while the abstractive path utilizes generative AI to create entirely new text. Both successfully deliver a reduced volume of salient points. As we conclude this deep dive into text analysis techniques, we must consider the architectural implementation of these workloads. When building an AI solution, architects have two primary paths for text analysis. First, they can leverage general-purpose large language models, or LLMs, through the Microsoft Foundry catalog. General-purpose models are incredibly flexible and can perform summarization, entity extraction, and sentiment analysis simultaneously by simply following complex natural language system prompts. However, because they are probabilistic, their outputs can occasionally vary. The second path is utilizing specialized, purpose-built natural language processing tools, such as the Azure Language SDK. These specialized services use underlying statistical techniques to return highly predictable, deterministic, and strictly formatted JSON results. For rigorous enterprise pipelines like automated PII redaction or high-speed sentiment routing, these specialized deterministic endpoints are often preferred for their unshakable consistency. Ultimately, modern AI agents orchestrate a combination of both, using an LLM for conversational reasoning while executing strict text analysis tools in the background. Thank you for joining this expert training module on identifying AI workloads. If you found this technical deep dive valuable, please like this video, subscribe to our channel, and share it with your engineering peers. To truly master these critical cloud concepts and accelerate your career, I highly encourage you to visit quicktechie.com. We offer premium certification prep, including comprehensive Q&A banks, detailed ebooks, audiobooks, advanced training labs, and expert interview guides. Build intelligently, deploy responsibly, and we will see you in the next lesson. Architectural governance requires that all text analysis operations be meticulously logged. Whether you are invoking a generative model for abstractive summarization or a deterministic API for entity extraction, your application must record the latency metrics, token consumption, and the specific workload invoked. This telemetry ensures that your NLP pipelines remain highly performant, accurate, and cost-effective in production. Our final flowchart maps the architectural implementation choice. Enterprise text analysis routes either to a flexible general-purpose LLM via prompting or to strict specialized Azure language APIs.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.